The solar power tower, also known as central tower, power plants or heliostat, power plants or power towers, is a type of solar furnace using a tower to receive the focused sunlight. It uses an array of flat, movable mirrors to focus the sun's rays upon a collector tower. Concentrated solar thermal is seen as one viable solution for renewable, pollution-free energy. Early designs used these focused rays to heat water, and use the resulting steam to power a turbine. Newer designs using liquid sodium have been demonstrated, and systems using molten salts as the working fluids are now in operation. These working fluids have high heat capacity, which can be used to store the energy before using it to boil water to drive turbines. These designs also allow power to be generated when the sun is not shining. Cost. The U.S. National Renewable Energy Laboratory has estimated that by 2020 electricity could be produced from power towers for 5.47 cents per kWh. Companies such as eSolar are continuing development of cheap, low-maintenance, mass-producible heliostat components that will reduce costs in the near future. eSolar's design uses large numbers of small mirrors, which reduce costs for installing mounting systems such as concrete, steel, drilling, and cranes. Improvements in working fluid systems, such as moving from current two-tank designs to single-tank thermocline systems with quartzite thermal fillers and oxygen blankets, will improve material efficiency and reduce costs further. Design. Some concentrating solar power towers are air-cooled instead of water-cooled, to avoid using limited desert water. Flat glass is used instead of the more expensive curved glass. Thermal storage to store the heat in molten salt containers to continue producing electricity while the sun is not shining. Steam is heated to 500 degrees Celsius to drive turbines that are coupled to generators which produce electricity. Control systems to supervise and control all the plant activity, including the heliostat array positions, alarms, other data acquisition and communication. Generally, installations use from 150 hectares to 320 hectares. Commercial applications. Recently, there has been a renewed interest in solar tower power technology, as is evident from the fact that there are several companies involved in planning, designing and building utility-size power plants. This is an important step towards the ultimate goal of developing commercially viable plants. There are numerous examples of case studies of applying innovative solutions to solar power. Examples of heliostat power plants' novel applications. The pit power tower combines a solar power tower and an aero-electric power tower in a decommissioned open-pit mine. Traditional solar power towers are constrained in size by the height of the tower and closer heliostats blocking the line of sight of outer heliostats to the receiver. The use of the pit mine's stadium seating helps overcome the blocking constraint, as solar power towers commonly use steam to drive the turbines, and water tends to be scarce in regions with high solar energy. Another advantage of open pits is that they tend to collect water, having been dug below the water table. The pit power tower uses low-heat steam to drive the pneumatic tubes in a cogeneration system. A third benefit of repurposing a pit mine for this kind of project is the possibility of reusing mine infrastructure such as roads, buildings and electricity.